So for this problem, 474 ones and zeros, this is a very good problem. Although I didn't post the video before, but I've solved this problem I think several times, and I still believe this is gonna be a really good problem. So let's just try to understand it first. So we are getting an array of strings, so it's gonna be the string, each of the string gonna be 0 and 1s, and we are also getting two variables, that is m and n. Yeah. Now let's just try to understand it. So we're going to return the size of the largest subset of strings such that there are at most m zeros and n ones. So this means this is going to be a limit. So for m, this is going to be the limit of zeros. So this means we can have at most m zeros, we can have at most 5 zeros, and we can have at most 3 ones. So this is just the idea. We just want to find the largest subset of strings. Yeah. So this is the meaning of subset. I hope we understand what gonna be the meaning of the subset. So for example, set 1 gonna be a subset of 1, and set 1 gonna be a subset of 1, 2. So this is just the meaning of the subset. Yeah. I hope you understand it. So this is gonna be the basic understanding. Now let's just try to understand the first example. So inside of the first example, we're gonna choose this subset. It's gonna be 0, 1, 0, 0, 1, 0, 0, 0, 1, and 1 and 0. And why it meets the condition? Let's just check the number of zeros. So the number of zeros is going to be 5. So this is okay. 5 is less than or equal to this 5. And the number of 1 is going to be 3. 1, 2, and 3. So 3 is going to be less than or equal to this n. It's going to be 3. So it meets the condition. And what's going to be the size of the subset? So it's going to be 4. So 4 is going to be the largest. So if we can also choose other cases, so for example this example, but the size of the set is 2, it's not the largest. So we're going to return the largest subset. Now, what's going to be the basic idea of solving such kind of problem? We are giving an array, and inside of the array, it's going to be something, we're going to call it 0 and 1 string. Yeah. So this means for each of the string, we can have two decisions. We can select it or not select it. So for example, we're going to select this one, 1 and 0. Or maybe we just want to select another one. Maybe we're going to select 0, 0, and 0, 1. We're going to select this one. Or maybe we just select this one. This is a 1, and this is a 0, 0. And we just want to select those 4 strings, and it's going to become a subset. So this is going to be the largest subset. Yeah. So this means it's going to be a 0, 1 knapsack problem, because we can select it or not select it, but we can at most do it once. And for the next time, we have to decide to choose the next number, next string. We can select it or not select it. Yeah. So if we turn this problem into a, first of all, we're going to turn it into a 0, 1 knapsack problem. So the second step is that what kind of algorithm we can use to solve it. So normally for me, I'm going to use DFS plus memorization, because this is going to be the easiest way of writing such kind of problem. Yeah. I think we can just get started. The only difficult part may be how can we control this m and n? How can we control how many zeros and how many ones? So that's going to be inside of the design. So I'm going to prepare a class, and I'm going to prepare the DFS. So from the beginning, I'm going to prepare an index I. So this is going to be from the beginning, index is going to be 0, and the I is going to be shifted to the next one. I'm going to decide to choose it or not choose it. Yeah. But I also need to control how many zeros and ones. So I'm going to prepare a variable 0 and 1. So this is going to be the control of how many zeros and ones. Because my final return is going to be the largest subset. Yeah. So this means I need to check the index I first. So if this I equal to capital N, because we have the lowercase n, so instead of lowercase, we need to prepare uppercase n. Yeah. So this n going to be the length of the strings. And I'm going to prepare a result. It's going to be the DFS. I'm going to call the DFS. It's going to be starting from 0, and from beginning, there's going to be 0, zeros, and 0, ones. And finally, I'm going to check it. So I'm going to return the result if this result not equal to the negative infinity, because we are going to check the maximum number. So this means inside of my DFS, definitely I would to set a negative infinity if it didn't meet, if I cannot find anything. Yeah. So this is why I'm going to return the result if this result not equal to the negative infinity. Otherwise, I'm gonna return a 0. So this is my design. Now I just need to finish the DFS. So if this I equal to n, it means it goes out of the range, and we need to have a return basically. But we have two decisions. We can return a 0, so this means everything's okay. We just need to have the final return. So this means everything's okay. So how can we check everything's okay? So this means 0 should be less than or equal to m. So this is the limitation. Or n gonna be less than or equal to n. Yeah. Otherwise, so we're gonna return negative infinity. Yeah. We're gonna set a negative infinity, or maybe you're gonna set a -1. I think it is okay, but for me, I'm gonna set a negative infinity because I'm gonna check it from here. It's gonna be the negative infinity. Yeah. Now, how can we start the DFS? Basically, we have two decisions. We can decide to take it or not take it. So what going to be our decisions? So from the beginning, maybe we want to set a negative infinity. Result going to be negative infinity. And our first decision is that we will not take it. So result going to be the maximum of the result with not take it. So it's going to be I plus 1. So the 0 and 1 will be the same. So what's going to be the next decision? Yeah, we're going to have a check. We're going to check the total number of 0 and 1. Yeah, so if the total number of 0 is less than or equal to m, and the total number of 1 is less than or equal to n, so we're going to update the final result. It's going to be the result with DFS I plus 1, and here going to be 0 and 1. Yeah. And finally, we're going to return the result. But this is not right, because currently, if we decide to take this number, we need to count how many zeros and ones, and we need to put it inside, because this is our decision to take this string. If we were to take this string, we needed to put how many zeros and ones inside, but currently we didn't do anything. Yeah. So this means from here, we need to check how many zeros and how many ones. So let's just prepare zeros and ones. I'm gonna count it. Yeah. So how can I count it? So I'm gonna use the strings I dot count. So in this way, I can count how many zeros, and I can use it to count how many ones as well. Yeah. And now, what I'm gonna do? I need to update the zeros and ones, right? So maybe I can use it directly. Yeah, let me just use this way. So 0 gonna plus equal to zeros, and 1 gonna plus equal to ones. Yeah, but this is too much coding. Maybe we can just simplify a little bit. Yeah. So what we can do? Let me just run it to have a roughly check. It seems that it is not okay. Yeah, because here I forgot 2 plus 1. Yeah, because here if we decided to take this substring, for example this one, take this string, we need 2 plus 1. This means we need to count it. Yeah, we need to put it inside our subset. Now let me just run it. As you can see, it works. Now let me just submit it. Yeah, as you can see, it passed, but it is a little bit slow, and it is too much coding actually. We don't need to write so much coding. It is not readable. Now I want to optimize a little bit about it. So how can we do that? So for this one, this is what we are going to take. We are going to select this one, and here currently this one is we are not going to select. And for here, this 0, 1 is just update. And what we can do, we can use this 0 from here. So 0 gonna plus equal to this one, and this is 1. So 1 gonna plus it equal to this one. Yeah. Or we can directly use this ones to count how many ones. Yeah, let me just optimize a little bit. So this zeros is used to check how many zeros. So this is okay. And inside, what are we gonna do? We're gonna put the zeros plus this zeros, and for the ones, it's gonna plus this ones. Yeah. Now I want to put it in one line. Maybe it is better. Yeah. So I will put one here and put it in one line. I think this is also readable. Yeah, but it is still too many lines, and I think we can still reduce a little bit. Yeah, as you can see, it still works. If I submit it, it still works. It didn't work. Let me just maybe this is how many. This zeros and ones, and yeah, let me just put this one just inside here, and finally I just need to return this one. I don't need to use the result, and I don't need to use here, and I will delete all those lines. Yeah. Now from here, this is for coding how many zeros and how many ones, and here if I select it, I will put it inside and I will plus 1 after the DFS. Now let me just run it. Yeah, now it works. Yeah, as you can see, but it cannot pass because for here on this ones and zeros can be a really big number. Let's just submit it. So it is wrong. Yeah, I think I did something wrong and I cannot find it. Because here, as you can see, I used this n. It cannot be n. It must be 1. 1 should be less than and equal to n. Yeah, you know, sometimes make the silly mistakes and can never find. Now let me just submit it, and we're gonna use this kind of code. Yeah, so here is a typo. Definitely it will be wrong. Yeah. Now what we're gonna have is that we're gonna have a time limit exceeded or memory limit exceeded. So because we didn't check the limitation of the zeros and ones, basically we need a training. So for zeros, we need to have a check. So if zeros is more than and is equal to m, yeah, more than m, or 1 more than n, so we're gonna return negative infinity. Now let me just run it to have a check. Yeah, as you can see, it finally works, and it is reduced a little bit time, but I think still this is okay because definitely DFS plus memorization is going to be a little bit slower than the DP solution. Yeah, but this is also a good way to solve dynamic programming problems. We can turn it into a DFS with memorization first, and this is basically basically helpful for us to understand what is the meaning of the problem, what is the 0-1 knapsack, and then maybe we're gonna try to use some advanced ways to like DP, like the real DP, to solve the problem. And let's analyze the time complexity. So inside the DFS, what are we gonna have? We're gonna have this I. So this is gonna be the length of the string. So it's gonna be the 600, and 0 and 1. So we need to check how many zeros and how many ones. So it is dependent on this m and n. Yeah. So currently this m and n with this 600, it's gonna be a big number currently. That is why it is so slow. It's gonna be 6 times 10 to the power of 6. Yeah, basically it's 600 times 100 and 100. Yeah. Now inside here, we are also counting how many zeros and ones inside here. Yeah. So if we want to count a string, how many zeros and ones, basically this also takes a time. Yeah, So for here, if we are going to code how many zeros and how many ones for each of the string, so if the basically we need a for loop. At least we need a for loop to count how many zeros and how many ones, and the length of the string is 100. So this means it's going to be times 10 to the power of 2. It's going to be like 6 times 10 to the power of 8. Basically, this is going to be a really big number. Normally, it cannot pass. But the problem is that we're going to have some kind of a trimming, maybe. We're going to control it. So if the zeros is more than m, because this m going to be a small number. It is just 100. Basically we're gonna control that zeros and ones. This means we're gonna neglect the analyze from here. It's gonna be a really small number, so we're gonna think it's gonna be 01. Because this m it's gonna be just like 100, and the length of the string is gonna be 100. If it is 100, because the zeros and ones are gonna be 100, basically we're gonna control it. Basically this one we're gonna neglect about it. I think the final time complexity maybe it is 10 to the power of 6. That is why we can pass. Otherwise, like this number, definitely we cannot pass. I think that's all for it. Thank you for watching. See you next time.